In this case, I'm going to show a more complicated variation of the last scenario we used in the demo. In this case, we are going to use not 3 but 4 different tools, which, like before, are permutations. But in this case, we have 8 variables instead of just 4. And we're going to see if we can pick 2 of these initial states and derive the other 2 using any combination of these 4 tools. It's not guaranteed that there is a solution to this, but we'll see. I'm going to have this here so you can see the time passing by. It's going to take a bit longer, but of course I challenge anyone, if you know a way to do this in more quickly with the resources that you see here. In this case, I'm using the CPU. Just let me know. This is as efficient as it can get. Not only the approach that is implemented is efficient, but this system is already working in a multi-threading capacity. It's not a linear process. Okay, we have a result here. As you see, it didn't take that long. And there's an interesting thing that happened is that the system is telling, unlike the systems that you probably are used to, which if there is no answer, they simply come up with an answer. As you can see here, the system arrived at the conclusion that there is no answer to the specific query, that is. It only found the partial solutions, meaning that there is no single way to apply a series of those 4 permutations that the system can use in order to go from these states and arrive at these 2 states here. This is a very different approach from the one you are used to in current AI models, because this one doesn't come up with an answer. There is no answer. It just tells you that with only these 4 tools, you cannot find an answer to this problem. And if you want, you can try yourself. And if you manage to find a solution to this, then it means that this machine is wrong, and you can just let me know. But as far as I can tell, this machine is working very well, and it's truthful, meaning that with the tools that it has, it cannot give you this answer. However, it did something interesting, that it still tried to find the best solutions to the problem. And in this case, the best solutions means the solutions that were closer to get to a complete answer, meaning that it could not connect all these 4 propositions in a logical way, but in some cases it managed to find a path between these 2 assumptions on the left, and at least one of the propositions on the right hand side, or vice versa. So this is what happened, and you can see this is a problem. This is an exponentially complex problem. We navigated here in an exponential complex geometry on the fly, because as you saw, The only thing that was in the database, was these 8 propositions. So everything you see here was generated on the fly. The system generated and navigated an exponentially complex geometry on the fly in under a minute or so that you just saw, which is a remarkable difference with the current AI approaches. And not only that, it could tell you that there is no answer to what you were looking for. And not only that, it even gave you the best answers that it can find with the tools that it has. And in this case, it found 4 solutions. You need to think about this for a minute. If you think about the complexity that the system navigated, it navigated an exponentially complex geometric landscape, which it generated on the fly, to give you a strictly logical answer. Moreover, it found that there was no single answer, no complete answer to your question. So, and not only that, it even found the best solutions, the more complete solutions to your problem, and it found 4 of them in an exponential complex geometry space. There were only the system managed to tell you in under a minute that there were only four best ways to logically connect the data that you gave it. I'll leave it to you to derive your conclusions from this. I think this is a very interesting example, and you can interpret the results in the same way as explained before. In this case, you can navigate the 4 solutions. Of course, the answers will change, but these are partial solutions in the sense that if you see here, we wanted to arrive at proposition 6 and 7. So if you see here, if this is a partial solution, you should only see one of those 6 or 7 propositions as a conclusion in these intermediate steps. So if you look, there's 6 here, you see 6 here in the middle, and 7 isn't here. That is why this is a partial solution, because it managed to connect those initial assumptions to only one of those conclusions. And probably one of those you could see on those other 3 partial answers or solutions that you could see 7 but not 6. Proposition 7 but not 6 on the right hand side. That's why they are only partial solutions. So this is a more extreme example that I wanted to give you. The system did all this with only, I think this is a 5-core CPU or something. You can look it out and you can derive your conclusions from this. Thank you very much.